Okay, so given our second problem here, we have a sphere. So Jamie wants to know the volume of a tennis ball, shaped like a sphere. Given that its radius is x plus 3 centimeters and its surface area is equal to 210 centimeters squared, find the value of the radius, x, and its volume. Okay, so we have here a sphere, and we all know that the surface area, the surface area of the sphere is 210 centimeters squared. And you also know that the formula for solving the surface area of a sphere is 4 pi r squared. So 4 pi r squared. Therefore, we can equate these two values to get the value of r. Okay, but therein lies the complication. Okay, so that's going to be 210 is equal to 4 pi r squared. Okay, so now that we know, now that we have an equation, we can substitute the value of r. Now r is equal to x plus 3, okay? So that's the complication. So that will be 4 pi, okay, so x plus 3 squared, okay? But it's not so difficult to compute, okay? So this is very easy. So this is just squaring a binomial, okay? Very easy, okay? So 210 is equal to 4 pi. So what's the square of the quantity x plus 3? So that's going to be x squared plus 6x plus 9. Okay? And from here, we can now solve for the value of x. Okay, so very easy. So we distribute 4 pi to the different parts. Okay, so that's going to be 210 is equal to 4 pi x squared plus 24 pi x plus 36 pi. Okay. 36 pi. Okay, and then we transfer 210 to the other side, so that we can solve for the value of x, and we find the two roots. So that will be 0 is equal to 4 pi x squared plus 24 pi, and then 24 pi x plus what's that, 9 times 4, so that's 36 pi, right? 36 pi, and then we minus 210 here on this side, and from here we can now solve for the value of x. So we have here x sub 1 and x sub 2 using our scientific calculator. Okay, so the one that I taught you a while ago. Okay, so if you didn't catch that, I'm going to teach you guys again. Okay, so we have here our scientific calculator, our Casio scientific calculator, and we're going to try to solve. Okay, so again, to solve for a quadratic equation, the two roots of a quadratic equation, we press mode, and then 5 equation, and then you press free. Okay, free. Okay, since it's a quadratic equation, you press free. If it's a cubic equation, you press 4. But since it's a quadratic, you press free. Okay, then you input the values. Okay, so we have here 4 pi x squared. So what's the value of a here? So it's not just 4, okay, so it's going to be 4 pi. Okay, so input that entire numerical coefficient here. So a will be 4 shift pi. Okay, 4 shift down here, so equals. And then we have b. Okay, so b is equal to 24 pi. Okay, so this is 24. Okay, 24 pi. Okay, so that's 24 pi x. So the numerical coefficient is 24 pi. Okay, and then we need to input the value of c. Okay, so the value of c is going to be a bit tricky. It's going to be 36 pi minus 210. Okay, so that's the value of c right there, because we transferred 210 to the other side. So it's going to be 36 pi minus 210 if you input that on your calculator. So you get negative 96.90. And if you equate that, then you try to find the roots. Okay, so we have here x sub 1 is equal to 1.09. Okay, and x sub 2 is equal to negative 7.09. Okay, So we can see already clearly here that the only possible root for x is 1.09 because we cannot have a negative root for a geometrical figure. Okay, so now we can solve for the value of r. Okay, so we know that x from the one that we solve here, okay, from the quadratic equation that we solve here, x is equal to 1.09, and this is the one that we substitute here for the value of r. So r is equal to x plus 3, so that's going to be 1.09 plus 3, so r is equal to 4. Okay, r is equal to 4. What's the unit here? Centimeters. Okay, so 4.09 centimeters. And from there, we can now solve for the volume of the sphere. Okay, so because we want to know the volume of the tennis ball that Jamie has. Okay, so given that the radius of the tennis ball is 4.09 centimeters, we can solve for the volume by simply using the formula 4 thirds, okay, pi r cubed. Okay, and the value of our r, okay, the value of our r here is 4.09 cubed, so that's going to be times 4 thirds pi. Okay, so you get that the volume is equal to, okay, 4.09 cube, okay, so that's 68.42 if you round off, times 4 thirds pi, so that's going to be 286.59. Okay, so that's 286.59 cubic centimeters. Okay, so this is the volume of the tennis ball, 286.59 centimeters, and this is the radius, and we have solved the problem for the sphere. Okay, so for the third problem, we have here a cylinder problem. Okay, so Mang Andy needs to fill a drum with the dimensions given on the left image. So the cylindrical container, or the drum surface area, the drum's surface area is 1,125 centimeters squared, okay, or squared centimeters. So find the value of x, okay, given on the image, and the radius and the height, the value of the radius and the height since they're given in algebraic expressions, and the volume of the drum. Okay, so we know that the surface area, okay, the surface area for a cylinder is 2 pi r squared, so 2 times the area of the upper, and okay, so that's the upper and the lower circles that we added together, so that's 2 plus 2 pi rh, the lateral surface area. Okay, simply substitute the formulas that the values that we have here. So SA is equal to 1,125 is equal to 2 pi. Okay, so what's our r squared? Okay, so r is equal to 5x plus 1, so we simply write here 5x plus 1 squared, and then plus, okay, plus 2 pi, and then what's our r again? So we multiply that. We will multiply here r, 5x plus 1, and then you have to multiply that to h, which is 9x minus 1. Okay, so we're going to have here two quadratic equations. So that's going to be 1,125 is equal to 25 times 25x squared, okay, so plus 10x plus 1, okay, and no, that's not 25, this is 2 pi, okay, so this is supposed to be 2 pi, yes, that's 2 pi times 25x squared plus 10x plus 1, and then plus, okay, so we have to multiply 5x plus 1 and 9x minus 1. Okay, so you get 45x squared minus 4x minus 1. Now we distribute the 2 pi here and the 2 pi here to get the value of x. So we get 1,125 is equal to, okay, so that's going to be 50 pi x squared plus 20 pi plus 2 pi plus 90 pi x squared minus 8 pi x minus 2 pi. And we need to transfer this constant to the other side. That's going to be 0 is equal to, okay, so that's going to be 0 is equal to 140 pi x squared when we add 50 plus 90 pi plus 28 pi x when we add 20 pi plus 8 plus 8 pi x, and then minus 1125 because 2 pi and then 2 pi will cancel out. And then from here, we can now solve for the roots of x, so we can find the value of x. So again, I'm going to show to you guys the steps. Okay, so these are the steps on how to find the quadratic and cubic roots of a function of any equation on a scientific calculator. And what the scientific calculator that we're using is Casio FX-991ES Plus. Okay, so just follow these steps, and if you follow those steps correctly, the value of x, the two roots are, okay guys, so we found the two roots using our scientific calculator on our Casio. So x sub 1, the first root is going to be 1.5 and the second root is going to be negative 1.7. Now again, we cannot have a negative root for our geometric figures, so this one is not the root. Okay, so the root that we need to substitute to get the value of the radius and the height of the cylinder is 1.5. Okay, so we substituted that here, so 5x plus 1, so that's 5 times 1.5, that's 7.5 plus 1, so that's 8.5 centimeters. That's the radius. Are we using the right units? Okay, centimeters, good. And then we have 9x minus 1, so 9 times 1.5, that's 13.5 minus 1, so that's 12.5 centimeters. Okay, so there we have now the dimensions of the cylinder, and from here we can now solve for the volume. Okay, because that's what's being asked. We found x. Okay, x is equal to 1.5, and we also found the radius, which is equal to 8.5, and the height, which is 12.5. We just need to find the volume, which is 1/3. Okay, so we just need to find the volume, which is v is equal to pi times r squared h, or pi r squared h, so that's going to be pi, okay, times r squared, which is 8.5 squared, okay, times h, which is 12.5. And the value of that, okay, the volume of the cylinder is equal to, which is equal to v, the volume is 2,837.25 cubic centimeters. Okay, so that's the volume of our cylinder here for the draw. Okay, so for our fourth problem, we have a cone problem. Alicia loves eating ice cream, so ice cream cones, especially the cone part. When inverted, the ice cream cone resembles the image on the left, together with its dimensions, the radius of the cone and the height of the cone. The volume of the cone is 412 cubic centimeters, so find the value of y and the value of the radius, the height, and the surface area of the cone. Okay, so we know that the formula for finding the volume of a cone is 1/3 pi r squared h, or 1/3 of the volume of a cylinder. So v, the given here, v value, we have here the volume, so we have here 412, okay, is equal to 1/3 times pi, okay, and what's the value of our radius? So that's 2y minus 3, so that's 2y, okay, 2y minus 3, 2y minus 3 squared, and then you have to multiply that by the height, which is 5y plus 9. Okay, so we are going to have here a cubic equation. Okay, so this is going to be easy to solve. Okay, very easy. So the first thing that we have to do here is we have to square the binomial. So that is, okay, 4y squared minus 12y plus 9, and we multiply that to 5y plus 9. Okay, so you get 20y cubed minus 20y squared minus 63y plus 81. And then we have to multiply each of these terms here on our equation to 1/3 pi, 1/3 pi, or pi over 3, and we get, okay, so we get 20 pi over 3 y cubed minus 8 pi y squared minus 21y, okay, 21y plus 27 pi. Okay, this should be 21 pi y, okay, plus 27 pi. Okay, and if we transfer 412 to the other side, so that's going to be 20 pi over 3 y cubed minus 8 pi y squared minus 21 pi y plus 27 pi minus 412. And from this equation, we can find the value of y if we use the scientific calculator here that we have for solving the cubic equations root. Okay, and if you use that scientific calculator, and if you input it using, again, these steps that I've taught you, so you can find the value of y, which are, okay, so we get 3 roots per y, 3.44, negative 1.11 plus 1.81i, an imaginary number, and negative 1.11 minus 1.81i.